So in previous videos, we've talked about how chemists can determine the molar mass for an element, for those beautiful things that are on the periodic table, by looking at that element's atomic mass. And that the mass of that element in grams is equal to 1 mole of that element. That's a game changer. That's really important when going between grams and moles for an element. And it's also important when finding molar masses of compounds. So just as we were able to use the atomic masses on the periodic table to determine molar masses of individual elements, we can use those masses along with a properly written balanced chemical formula to determine the molar mass or molecular weight of a compound. So here is where being able to properly write a balanced chemical formula is really going to be important, because you can see that if your chemical formula is not written correctly, then when you calculate the formula weight or the molecular weight, also called molar masses, all of those three terms mean the same. If your written chemical formula is incorrect, then your molecular weight calculation is going to be incorrect. Because to find the molar mass of a compound, you need the balanced chemical formula, and you sum the individual atomic weights for each atom in that molecule, and then slap a grams per mole sign on it. So for example, with magnesium nitride, Mg3N2, each magnesium is 24.31, so I multiply that by 3. I add 2 nitrogens, or 14.01 times 2, to get the formula weight or molar mass for magnesium nitride. So that means this means that 1 mole of magnesium nitride weighs 100.95 grams. So you should feel comfortable being able to calculate the molar mass for a compound. I have some examples here. I would encourage you, we're not going to walk through all of them. I would encourage you to try determining the molar masses for each of these. Let me get my little pointer here. Hint that remember that numbers, subscripts that are outside parentheses, they go to everything inside the parentheses. So for example, in calcium nitrate, there are 2 nitrogens, and then for oxygens, there are 3 times 2, or 6 oxygens. So I would encourage you to try to calculate the molar masses of those for your own. Those are the correct answers, and I generally write molar masses to the 100th decimal point because that's what's given on your periodic table. So now that you know how to find molar masses of compounds, you can do similar type of mole calculations using compounds, and we will do some of those in subsequent videos.